Hi, my name is Joseph Gorres. I'm at the University of Vermont as a soil scientist, and I also am the co-director of the Healthy Soil Collaborative that you'll hear about a little bit later on. And what I'd like to do is, you probably have heard a lot about jumping worms by now, but I like to get into some of the costs that are associated with jumping worm invasions. So what is the price that we pay for these worms? And I should say I'm not an economist, so I just pulled out numbers that are available in my life, my checkbook, but also numbers that are in the literature. So let's get started. So earthworm invasions cost money, absolutely, real money. So if you really think about it in the global context, earthworm invasions are causing or part of a couple of global crises, like the mass extinction event that we're in right now, the degradation of natural resources like water, air, soils, climate change even. Um, and of course, there is that we need more research done on invasive earthworms, which is also a cost in the end if you wanted to stop this plague. So I always think about earthworms as really positive things. I'm from Europe, and there we say, earthworms, cool. More earthworms. We have a really good idea of what earthworms do for us in terms of ecosystem services. But in reality, there are problems when they're invasive, when they're getting into areas that they weren't before. And I don't just mean get into the areas, the formerly glaciated areas where there was no earthworms at all, but also into areas where there are native earthworms and where they are competing with the native earthworms. Right, so this is a very famous image by Lee Froelich. It's a view chart of what the effect of an earthworm is on soils, and then at a much larger scale on society and other ecosystems. So at the microscopic scale, earthworms basically change soils. They change the soil structure, they change how much organic matter there is in the soil. That has an effect in turn on nutrient cycling, including nitrogen and phosphorus, has an effect on temperature, has an effect on moisture, and that in turn has an effect on um, the microbial processes and the microbial communities that are part of the food web that connect the soil with things like nematodes and protozoa, and then at a much larger scale, maybe birds and other bigger animals. So there is a huge effect on habitat that affects, as I said, the microbes, but also larger animals. Um, the first thing that you probably see when there is an earthworm invasion is that there is a change in the plant community. You no longer see a really dense understory in the forests, and I'm sure that you've heard about this already. Um, and that changes the habitat for vertebrate species like salamanders and birds. So that is at the very small scale. So going from small scale, like a small chunk of soil, all the way to the stand of a forest stand that may be a few acres in size, and maybe even bigger than that. But those changes then kick off other changes. Another part of the cascade is this macros cascade. And that's where costs and benefits come in. Right? So that's where we are really affected. And so the effects that people have listed, and they're listed here, are disease dynamics. Earthworms can have an effect on human disease, and that doesn't necessarily mean bad. For example, a friend of mine always says, you have earthworms, and in your backyard, then they will take care of the litter fall in the fall, and that means that there is fewer ticks, which means there is probably less Lyme disease. But that is, there may be other diseases that are encouraged by this, by the invasion. Things that happen as well is that earthworms facilitate the invasion by other organisms, like plants, like multiflora rose or um, uh, oriental bittersweet. They come in and they cause a cost, right? Some people actually go out and try to pull them out and restore forest or restore somebody's backyard to what it was before without these invasive species. Um, there's an effect on plant community composition, which you can probably surmise from what I said about the facilitation of invasive species. So that is a change in plant community composition, but the natural plant communities change as well. Wildlife habitat changes, and there's an example of that. If you have an invasive earthworm species and invasion, and the plant community changes, and you no longer have an understory in the forest, then the chance that a ground nesting bird is going to be impacted by nest predators is much greater because the ovenbird, one of the birds that might be affected, their nests no longer have ground cover and therefore they're discoverable by nest predators. Forest and crop productivity, so depending where you are, it might be a positive effect and a negative effect. For invasive earthworms, probably a negative effect. Soil and water quality are going to be changed, not always for the better. So again, in Europe, soil quality, earthworms, super. But here in the northeastern part of the US and into the southern parts of Canada, soils have developed without these earthworms, and therefore um, any kind of modification will lead to a change in the ecosystem. It's climate change and carbon dioxide, and then finally there's disturbance regime. How often does wind and fire occur in the forest? How strong are the winds, and how much effect do they have on fire? So real costs. I should say that we really don't know much about the costs that are associated with earthworms. But I like to get into that in a little bit, so maybe we can get some estimates. Right, so the damage cost of all biological invasions in the world from 1980 to 1920 was $1.2 trillion. So that is of the same order of magnitude as the effect by big storms like tornadoes, hurricanes, etc. So it's of the same order of magnitude, and that's huge amounts of money, $1.2 trillion. And people think that that is an underestimate, but I can't argue with that. So how does that impact your life? So I can talk about, ecological cascades and how all these things happen to society and to your local woodlot and stuff like that. But what does that mean for you? And so I'd like to share a little bit about that, and I'll get into my origin story with jumping worms in a minute. So I'll be talking about my home, like lost mulch, quality of plants, quality of life. Like, so people get upset when they have these worms, and that is not really good for the stress level and the blood pressure of those poor people. At your nursery, often nurseries report that they have to replace potting mix in pots because it's being consumed by jumping worms. Cost of the control. How much does it cost to apply a vermicide? And I would like to say right away that there is no registered vermicide. So it is actually illegal to apply a pesticide with the intention of killing earthworms, because earthworms are not on any of the labels of the regular pesticides. Agriculture, is it a plus or a minus? We don't know. At least here in North America, that's a really good question. In Europe, oh, it's a plus, of course. Um, in the woods, there's a loss of carbon and biodiversity. At your faucet, there might be a cost to water treatment. We'll get into that a little bit later. Biodiversity, priceless, question mark. Forest products, maple syrup, priceless, question mark. Human health, insanity by worm. Chill, people. Just relax. Help is underway. Hopefully, I'm saying that. Um, and then there's the effort for control and damage mitigation, right? So control means, can we develop a pesticide that can be registered with the EPA but also registered in the individual states because the two registrations for pesticides are different. States have usually a more stringent pesticide law than the EPA does. And damage mitigation, well, if you have a damaged ecosystem where the understory of the forest is gone, is there a way of restoring that? So starting in my yard, this is the house I bought in 2010, in April, just before the Obama subsidies went away. So I earned $10,000 there. But the house has changed a lot. And what you see there is, you have a bare bones house, and then you have a couple of areas that are mulched, right? So right here is a mulched area. There's another one, and this bed extends further back. And then there's another area here. And the backyard also had a couple of mulched areas. Um, so house in April 2010, the flower beds were prepared with 4 inches of hardwood mulch by the previous owner so that they could sell the house quickly. The mulch was gone by August. The same year, that was really fast, right? So mulch doesn't disappear that fast. And when I was investigating, using my soil science skills, I found an abundance of jumping worms. And I'd never really seen them. It's really crazy. I've heard about them. I was like, oh yeah, those are these really active worms. So I was really surprised to see them in Vermont, cold place. In the meantime, since then I've learned that they've probably been around for 20 or 30 years, so way before I bought that house. But I also learned that mulch is food for those worms. And so here's one of the culprits, Amynthus agrestis, sitting on top of my mulch way back when. So what is the cost of mulch if you install it yourself, right? So I mulched the area in 2010 with 3 inches, or a little bit less than what there was originally, on about 0.01 acres, so a hundredth of an acre. That was the flower beds, and I paid $25 per yard, and I needed 3 yards of mulch to replenish what the worms consumed. So I spent about $75 plus or minus. Now I have much more of a mulched area. And so I have more of a 0.05 acres. And again, if I mulch with 3 inches, then that means I need about 18 yards of mulch to replenish what the worms consumed. And that would amount to about $540 every year with the worms. Without the worms, it would only be $160. So it's a real cost to the homeowner. And then you imagine that you have more areas that you mulch, you're a very active gardener with a bigger property than mine, then you're probably going to spend a lot more money on mulch. And if you just want to get this in a per acre number, then this is what it would cost you, about $7,000 per acre per year, more than without jumping worms. So that's a real number. That's some money. So at nurseries, potting mix is affected, right? So nurseries often report these kinds of effects. Loss of potting mix from the pots. So you pick up a pot, a gallon pot, and you pull out the plant. And usually when there's jumping worms in that pot, you can easily pull that material out, and you notice that there's half of it missing. And that also oftentimes that translates into drought-like symptoms in the potted stock, and you will see root damage, right? So you pull the plant out, look at the roots, they often discolored and missing in the bottom part of the pot. So the nurseries need additional potting mix when repotting. And so how much would that be? So if medium nursery might have 15,000 1-gallon pots, and that's about 12,500 gallons. They have 5,000 4-inch pots. The combined volume of those 5,000 pots is 1,500 gallons. And then so together it's 1,400 gallons, which is 80 yards. Let's assume 75% of that is initially filled with potting mix. It's about 60 yards. And assume that half of that is lost to jumping worms. So now you have 30 yards that you have to replace. And so the cost of a yard of potting mix is $120 here in Vermont. So if you multiply the 30 yards by $120 per yard, you get $3,600 that you have to spend more on potting mix. And so these are numbers I kind of pulled out of my hat. 15,000 1-gallon pots sounded reasonable, according to my wife, who was a horticulturalist, and 5,000 4-inch pots sounds reasonable as well. So uh, make sure that when you see that $3,600, that you have a plus minus like $500 or something on there to make sure that estimate is sort of within a range that is reasonable for a mid-sized nursery. So we have experienced this ourselves. Um, Cornell University about 10 years ago put a fact sheet out, and University of Maine as well, that said, okay, so if you have these worms in your pots, then you see drought symptoms, as I mentioned, and you might see some mortality of the plants due to that. So we said, okay, let's try an experiment. Why is that? So many people think that it's the castings that they produce. Earthworms produce these loose castings, and that if you plant into that, the uh, the plants just don't take, right? So we bought some cilantro plugs so to give the plants a head start. We didn't start from seed, and we planted them into 3 different situations. One was just we potted the plugs into a potting medium with no jumping worms present at all. Then we did the same thing into the same potting mix, but that had plenty of castings because we had worms in there for 2 weeks prior to planting. And then we had plugs that we planted when the jumping worms were added. So at the very same time that we planted, we put the jumping worms in. And so what we found is that the cilantro plant's doing pretty well. Actually, did very well uh, when we planted into potting mix without the jumping worm. So it's on the left-hand side of the panel, vigorous growth. When we planted the plugs into the castings that were already there, we had stunted growth. We saw mortality, and we saw drought symptoms, just like it was predicted by Cornell and Maine fact sheets. And then when we planted them into potting mix at the same time as jumping worms were added, we had mixed results. In some cases, we had mortality. In some cases, we had vigorous growth. So this just goes to show that there are real effects, and the effects may not always be the same for all plants. Some plants might thrive, and we don't know. We don't know that. So there's sort of a need for research to find out, what are earthworm or jumping worm hardy plants that we can use. So control measures, as I said, there are no legal control measures right now that are based on pesticides or devices that are pest killing devices, right? So essentially, but there are some really good candidates, and they're usually based on saponins. Those are substances that are in plants naturally, and they're kind of little soapy, savon, French for soap. And if you wanted to buy one of those saponin-based controls that are not legal currently, we're working on it, or I should say that Vera Krishik is working on this. A quarter of that costs about $70, and that $70 covers about 4,000 square feet, which is 1/10 of an acre. So it covers my mulched area twice. So it's probably enough for 2 annual treatments in my garden. The big question is, does it kill all life stages of the worm? So these are effective against the worm form of jumping worms, but how good are they to kill the cocoons, the egg cocoons, which are survival structures for these worms? And so more research needed, right? So I'm just saying that all the time. So you notice how the research cost is going up and up and up as we go along this talk. And then, of course, there's, in a nursery, you might want to have a drench that is effective for pots that you buy, right? So again, research needed. What kind of drench and how much of that drench and how much of the drench is wasted, and how much does that cost the nursery for 15,000 1-gallon pots? But that's not all. This is not where we're going to stop, right? So we now looked at things really close to home, and then we looked at things a little further away from home, nurseries where we get our plants. But let's take a trip to the Catskills of New York. So New York City protects watersheds that provide their drinking water. New York City has high quality drinking water, and the reason for that is because they're getting it from natural areas. Right, so not pulling it out of the Hudson or the East River, they're getting it from the Catskills. So most of it comes from the Catskill Delaware watersheds, just northwest of New York City. And then there's a smaller watershed, the Croton watershed, that is close to New York City. One of them is so high quality water that it doesn't have to be treated. Right, the one from Catskills in Delaware, that water doesn't have to be treated at all. The one from the Croton watershed, which is much closer to the conurbation, has pollution in it and needs to be treated. The New York City water supply system people are kind of worried about, pollution getting into their Catskill Delaware watershed, which that would mean that they would have to build a water treatment plant for that, and they're not cheap, right? So before I get to the cost, I'd like to just answer a question that you probably have in your mind, which is how can earthworms affect water quality, right? So the image that you see there shows you erosion of a forest floor during a big storm in July 2024, when part of Montpelier was flooded for a long time. It was a big storm. And you notice that there's sort of areas that are scoured in this forest, and that's basically soil loss. There's about 1 to 2 centimeters of soil that were washed away. That soil consisted mainly of castings that the earthworms produced. So if you were to estimate that, over an area of about an acre, then you get about 36 cubic meters of soil lost, which is about 45 short tons per acre. All that went into the Winooski River, and some of that sediment probably made it into Lake Champlain. Those castings are high in nutrient content, so you're providing all the algae Lake Champlain with more nutrients to grow. So that is a problem. So this is a super big problem, because that is now a water quality problem. There's about 13 times, so that erosion is about 13 times more than what the USDA considers their tolerable soil loss for that soil type. So tolerable soil loss is roughly a rough estimate of how much soil can regenerate per year. So you're losing 13 times the amount of that. So it's a big loss of soil that can produce water quality issues when it gets into the wrong place. Excuse me. So how much does New York City, New York City save by protecting watersheds? Well, the main saving is avoiding the water treatment. So if they had to build a water treatment plant, it will cost them $6 to $8 billion. And then the treatment of that water coming off the Catskill Delaware watershed would be about $300,000 in annual operation. That's big money. That's money that you don't have to spend on your water bill, right? So that's, again, comes home to you, to your personal accounting. So New York City water supply is actually pretty big, 1.3 billion gallons of water every day, and 1.2 billion of that come from the protected Catskill Delaware watershed, and the other 0.1 billion comes from the Croton watershed, which is not protected, and that water has to be treated. So talking of erosion, erosion is costly as well. It costs agriculture productivity. It leads to sedimentation of reservoirs and waterways, which for reservoirs, it means that the amount of water that you can pull out sustainably from those reservoirs becomes less. And if you wanted to improve that, you would have to go in and clean it out. You would have to dredge that reservoir. There's eutrophication of lakes, and you think, oh, eutrophication, so we don't go swimming. But you not going swimming at the beach means that, the hot dog stand doesn't make any money, and some other businesses around the beach will not make any money, right? So this happens every year in Burlington and in St. Albans, where I live. The town beach is closed down, and then the ice cream shack around the corner doesn't get too many takers for ice cream, right? But it also represents loss of carbon from the soil, which I'll talk about in a minute. The estimate of how much erosion costs has this really wide range of numbers. Like Pimentel et al. In 1995, so a researcher at Cornell wrote this seminal paper on the economics of erosion, and he came up with a number of $44 billion annually spent in the US for the prevention of erosion and the cost of productivity loss. But if you just looked at the farm income, Crossan in 2007 estimated $100 million would be that. The people that are charged with erosion reduction is the Natural Resource Conservation Service, NRCS for short. And in the Farm Bill of 2024, they were given $3.3 billion to implement a variety of conservation measures, including erosion. So that $3.3 billion does not necessarily include, does include erosion, but it's not all erosion money. Like there's other things like things that have to do with nutrient conservation on the farm, and a couple of other things that the NRCS is administering as well. So that I mentioned carbon before. Erosion is a carbon loss, but carbon loss is not just comes from erosion, but it comes also from the consumption of organic matter by earthworms or by other creatures as well. It's just that earthworms accelerate the carbon or the decomposition of organic matter, and therefore the carbon loss from the soil really, really quickly. The image that you see there in the middle is a very healthy forest floor. In this case, it got about 6 inches of this really high organic matter layer that is very fluffy. It contains roots. It contains fungal hyphae. This is where forests get a lot of their nutrients from. If that goes away, then the forest is going to be starved a little bit of the nutrients, and they still can get nutrients from further down in the soil. But this is where a lot of the decomposition happens, and all the mineralization of nutrients into plant available forms. And so we really want to conserve that. And it's also in the forest, it would also be the germination medium for ephemerals and maples and whatever else you have. And the place where seeds are stored for, bad years. So carbon is really important. In this layer of soil is really important for many different reasons. But there is something called the carbon market, and it's a tool to tackle climate change. And regardless of how climate change is happening, you may want to conserve carbon in the forests and in other places, right? So the carbon market is very similar to the sulfur market that allowed us to reduce acid rain in the 1990s. Okay, so this is how it works, right? So basically, there are heavy carbon users like industries and fossil fuel energy producers. And then there's people that work really hard at having a good ecosystem where a healthy ecosystem where carbon is sequestered. And so the people that produce a lot of greenhouse gas emissions can actually buy carbon credits from the people that are sequestering carbon. And in that circle, when that circle is being tightened every year, that basically means there's only so many carbon credits that are available. It means they're becoming more expensive, which means that the industries have to become more efficient in their carbon use. That can drive down the amount of carbon that goes up in the atmosphere. And again, regardless of how you think about climate change, it is happening. And so we want to actually find some really good market-based and engineering-based solutions to help us overcome that problem. So how much money can you make? And again, if you are a small woodlot owner, you can actually make money out of this. So if you look at the Northern Forest, which is where the Healthy Soil Collaborative is based, so from Nova Scotia and on the East Coast all the way to Minnesota, the middle of the country, that's basically the span of the Northern Forest. And there's about 90 million acres of forest land in the Northern Forest region. And excuse me. And if you only look at the forest floor material, there's 10,000 pounds of carbon in that per acre in that forest floor. So of the 130,000 pounds total carbon per acre, 10,000 pounds are in the forest floor. So assuming that earthworms only affect the forest floor carbon, then we're dealing with carbon credits that could be up to 10,000 pounds of carbon per acre. Excuse me. So in a carbon market, carbon has a price, and the price of carbon oftentimes depends on where on Earth you are and when on Earth you are, right? So at the moment, the carbon price is very low in the United States. About 0.8 cents is your carbon price per pound. During the Obama administration, it was 4.8 dollars per pound, 4.8 cents per pound. In the EU, it's the projection for 2029 is 11 cents per pound. If you then calculate out what those 10,000 pounds of carbon in the forest floor are worth, then you get prices per acre. You get $80 per acre during the Trump administration, $480 during the Obama administration, and 1,100 dollars per acre in the EU in 2029. So the value of carbon in the Northern Forest, the forest floor carbon, is $7.3 billion during the Trump administration, $43 billion during the Obama administration, and 99 billion during in the EU in the near future. So assume that you have a small woodlot of 20 acres, then depending on where and when on the planet you are, that turns into $1,600 to $22,000 in carbon offset markets. That again is real money. And if you're a small woodlot owner, you are interested in managing that woodlot really well, and you probably need some money to do that. You can generate that for sure by selling some of the wood, but wouldn't it be nice to get some extra to have some recognition that you are helping with sequestering carbon. Okay, so we're now going to get to the really hot topic in Vermont, and that is maple syrup, right? So Vermont is the major producer of maple syrup in the US. It's not as big as Quebec, but together they produce 80% of all the global maple syrup uh, from hardwood forests or from maple forests, right? And the value of the market is $1.6 billion in 2025. That's globally. So there's people in Japan will love this, but people in Europe love it. They say, oh, it's better than sugar. They will use maple syrup instead. So this is an expanding market, and the expectation is that that global market will rise to $3.0 billion by 2034. So that's big money. Now, why is this important for this talk, right? So what people find is that the understory of a forest that's invaded by jumping worms is depleted, and by other earthworms, by the way, as well, here in the northern part of the US, and southern Canada. They find that the understory is just not there anymore. And that includes maple saplings. So here's an example of this. You have a plot that is not invaded, and you have a plot that is invaded, and the amount of vegetation that is in differs between these two very highly. So you can see the bare ground in where the earthworms have invaded, and in the other case where the earthworms are not present, you have a decent understory. And so how do these images translate into sapling counts for maple? And so there was a study that I was part of in about 10 years ago. We went to 50 odd maple stands. Actually, sugar bush where actually maple sugar was produced. And we surveyed those stands for earthworms, and we also then measured all sorts of different things, biomass of the understory, and we measured the number of saplings, and this is number of maple saplings, red maple and sugar maple, depending where you were. And the area that we surveyed varied from northern Vermont all the way down into southern Connecticut. And the answer is jumping worms reduce the number of saplings that are there on average. So these are average numbers. In some cases, there was absolutely zero saplings. In other cases, there were maybe 5 or 6. And so the average was about a half a sapling per square meter. So this would be this number here. If you have night crawlers, another invasive and damaging species, you would get about three saplings on average across New England and a bit of New York. And then if you have snow earthworms, this goes up to 6. So those are big numbers. There are big differences between these things. So basically, what I usually say in Vermont when I want to scare people is if you have jumping worms, then you can't get any sugar maple anymore, and you will have to resort to table syrup by the end of the century. So there's some other costs that are not so easily estimated, like the potential for increased wildfires. Probably depends on the type of earthworm, but if you really look at that, you kind of say, well, there's probably other factors that are much more important in determining fire risk, like heat waves in Europe or lack or drought or something like that. So a much greater effect than the earthworms would be. So I'm not even going to talk about that much. The effect on biodiversity, lower understory plant diversity, that's what we see all the time. There's effects on salamanders and arthropods. Then there's the effect on soil and water quality. So greater erosion potential due to the ease with which castings are eroded will lead to a diminishment in the fertility of that soil. There's loss of nutrients to groundwater. And just to show you an example of this, so this is total nitrogen concentration in leachate from experimental setup. And what you see there is data spanning from July all the way to November last year. The concentration is measured in milligrams per liter, and this is a log scale. So down here, you're talking about maybe 1, 2, where this 0.1 is, and lower than that, 1 or 2 milligrams per liter of nitrogen. And up here, you're talking about 40 milligrams of um, nitrogen um, in that leachate that will eventually get to groundwater. And if you have a well, then you're pulling that water out of the ground, right? So you would have, if there's a lot of invasion around you, you might have more or less trouble. So the first number here you see, well, so you have two treatments, a control and a jumping worm treatment. The control is green and the jumping worm treatment is red. And you notice that at the beginning, so this is the beginning of the experiment, these two were exactly the same because the jumping worms hadn't done anything yet. But then as you go through the summer, there was no rain, there was hardly any rainfall, or if there was rainfall, there was no leaching because the plants were picking up the water and didn't allow too much to percolate through the soil. Well, if you get to the big heavy storms in the fall when the plants are becoming dormant, you see leachate water, right? And that leachate water for jumping worms is about I would say 5 or 6 times higher in concentration than the control where there's no earthworms at all. And that continued into November. But usually the first big storm will flush a lot of that nutrient out. Just for reference, the EPA standard for drinking water is 10 parts per million. So 10 parts per million, so 10 milligrams per liter of water. So the jumping worm numbers are way above that 10 parts per million. All right, so then there's lost revenue for forest and horticulture products. Nurseries report unwillingness of customers to buy their products if jumping worms are present. So we don't know. That's really a question for the extension service and the economists that have a better understanding of both the processes that go into running a nursery and the processes that happen in the heads of nursery owners, right? So they have a much better rapport with them than researchers have. And so we're hoping that extension service, and I know that there are some already in Minnesota for sure, that are working on this kind of stuff. So biodiversity price tag, again, really difficult to nail that down for earthworms, but the world spends $166 billion to protect biodiversity, and that is protecting biodiversity from all kinds of threats that you see at land and at sea. And if this has to be effective, then this has to go up to 1 trillion by 2030. It's projection by Bloomberg. Inactivity on this would cost you 2.7 trillion of global GDP losses for not protecting biodiversity. There are actually biodiversity markets, much like the carbon credits, but they're so much more complicated. I don't really want to get into those. But again, it's difficult to put a price tag on the impact of invasive earthworms on biodiversity. So how much of the 166 billion is actually spent on earthworm control? And I would say none, right? So it's really difficult to get a number for that biodiversity issue. And then we get to the need for and cost of research, right? So if you want to do something about jumping worms, which is sort of the consensus among many forest ecologists and homeowners, then there's many unanswered questions. We want to know how do jumping worms spread, right? So what kind of geographic distributions do they have right now, and what is that distribution likely to be in the future, right? So if we can predict where they're going to be likely, then we can target areas for control, which makes us a lot more efficient than if we were to throw any kind of EPA and state certified pixie dust on the land to kill the earthworms. So there's currently a mapping project that's being developed to do that. What is the impact? What's the impact of invasive earthworms on natural resources? Like there's costs. What are the costs? There are costs, we know that, but can we estimate those a little bit better than a soil physicist can? So we need economists to chime in and maybe come up with some value or for some value of the earthworm or some cost of a single earthworm. Then what are control methods and how can they be approved by pesticide regulators? Like currently there are no approved herbicides, but there are some candidates for approval. And the University of Minnesota is working on this. Vera Krishik is working on this. But then once the EPA has approved the pesticide and it goes on a label, then you have to deal with state regulators. And then we have to ask, hey, what do you need from us for you, state regulator, to register this pesticide for earthworms? And so then we'll probably have to look at human health impacts and efficacy data and pollinator data as well. And again, here's that theme of research that goes through all this. And then what are good strategies for restoration of affected ecosystems, right? So which plants are resilient enough to withstand both the earthworm problem and climate problems, right? So whatever we do now to restore something to what it was before the earthworms arrived may not be what you want after climate change has changed the ecosystems or the conditions of ecosystems under which the ecosystems are developing. We would have to probably find ways of rejuvenating the soil, which can probably be done with vegetation. And we want to prevent invasive species, including invasive earthworms, to get into those areas we're restoring. So how much does university research cost? That's probably something you want to know right now, right? So at the University of Vermont, and I'm speaking only for the University of Vermont, a master's science or PhD student costs about $50,000 a year, and that number is to go up. Graduate students are unionizing, and so you can probably add another $10,000 to that in a couple of years' time. If you wanted a postdoc, so somebody who has a PhD already and who wants to earn some credits towards becoming a faculty member, you're probably talking about $80,000 per year in salary and benefits. If you want to really run a good experiment, you probably want materials and equipment that you need to buy, and the typical project probably is about $30,000 per year on that. If you wanted to install some big like a big worm experiment outdoors, then you're probably talking about $100,000. Anyway, this is not cheap for just one single project. Like for just one question, how much nitrate is leaching into groundwater? That would be probably $100,000-$200,000 project. But if you compare that to what the private sector would ask, it's cheap. University research is cheap, regardless of what people tell you. So a typical research project with the NSF, several million for an integrated project that addresses several points. USDA, National Institute of Food and Agriculture, which is the research arm of the USDA, they give you $600,000 maximum. State of Vermont projects are usually about $50,000 for research projects that deal with some things that also have market components in them. Like, for example, can we develop a market for quince in Vermont? Interesting question, right? And all of these grants are super competitive. So the likelihood of getting one of those grants is 1 in 20, if not worse. And then finally, there's philanthropy. So we've been pretty successful in getting philanthropic money. And thank you to the funders. And that's a lot easier if you find the right person. And so finding the right person is probably just as hard as getting an NSF grant. So bear with me. So in order to make more of an impact on philanthropy and maybe even on at the national scale, to have a better chance of getting grant money, we founded the Healthy Soil Collaborative, which currently is dealing with jumping worms, but in the future it might be dealing with other soil health issues. And we quickly started to understand that jumping worms are a really complex problem. We need to look at the spread, the impact, the control of jumping worms, and what we do for restoring the ecosystems after we've dealt with killing them all, right? So um, for the spread, we really want to know what are the regions at risk so we can target any kind of control measures. Impact and control, that goes into certification registration. You want to have something that says water quality is affected, greenhouse gases are affected, biodiversity is affected. Hey, something has to be done about this. There's a market for control measures. The control, yeah, so that hopefully leads to certification. Um, and you need to work with the horticultural trade. You need to work with uh, uh, legislatures and regulators and with the pesticide industry to make all this happen. Right. So typically, when people do research, there's these little ivory towers, right? Those people that work together generally, like soil scientists, ecologists, and biochemists. They work together and they do a little thing in the side. And then there's the people that do experimental control, or they do control measures for integrated pest management. So you have the integrated pest management specialists, you have the horticulturalists, outreach specialists, and they work probably with farmers and hort industry people. Um, but they're working oftentimes very separate from what the ecologists and the soil scientists are doing. And then there's the other realm, the regulators and the pesticide industry. There's another different group of people, and so they do their own thing, and oftentimes they cannot do anything unless there is somebody saying there is a need for this. And both the ecologists and the IPM specialists might say, "Hey, there's a need for this. We're seeing all these negative impacts in the industry. Let's do something." Right? For us, for the Healthy Soil Collaborative, we're more like this, right? So we have, nursery forestry industry, we have the outreach specialists, soil scientists, IPM specialists, biochemists, biogeochemists, horticulturists, philanthropy, homeowners, ecologists, and we all have looked at this and we said there is a problem with their spreading, there's an impact, we need control, we need restoration. So here's your market need. Let's do something. So we work together. We're not just waiting for somebody else to do something. We talk to each other, right? So it's a much more integrated effort that we are providing. And we're trying to have an impact on the pesticide industry and the regulators and the nursery owners and so on. So concluding, jumping worms are part of that $1.2 billion of damage that was done by invasive species from 1980 to 2019. Right? So is that the real value of it all, for all of the invasions, or is it more? We don't know, right? So more research needs to be done. And how much of that 1.2 billion can be attributed to the jumping worms? Question mark. We don't know, right? So, but we know that at the very personal level, at least I have to spend $560 in mulch every year um, to uh, to replace my mulch. So bringing it down to you, this is what happens. So thank you very much for listening, and hopefully we'll see you around somewhere in the country.